In this lesson, we're going to be focusing on graphing quadratic functions. So I want you to know that a quadratic graph either looks this way, that is, the parabola opens downwards when the coefficient of s squared, which is a, is negative, or it opens upwards like this. This will happen when the coefficient of s squared, which is a, is positive. Now we need three key parameters to graph a quadratic function. Now those parameters are: number one, the vertex. So this vertex is also known as the turning point, and this is the point on this graph or the parabola where the parabola changes direction. For example, if you take a look at this one, so at this point, let's say at this point, this is the point where this parabola changed direction. If you look, the thing is coming down, then immediately it reached at this point, it started moving upwards. So this point where this parabola changed direction is called the vertex or the turning point of this parabola. So same thing is applicable to this yellow one. So we can say that this is the point where it changed direction. So we need this vertex to graph a quadratic function, and it has both x and y coordinates. So the second key parameter we will be using is the x-intercept. So x-intercept, which is the root of the equation. So this is what we popularly call the roots of the equation. So the third parameter we need, which is number 3, and note this x-intercept is gotten by equating y to 0 and then solving for the values of x. So this is how the roots of the equation or the x-intercepts are gotten. Then the third key parameter is the y-intercept, so which is gotten by plugging 0 for all the values of x here and then solving for y. So in that case, the value of y is going to be equal to this c, because by the time you're solving 0 here, everything here is going to be 0. If you're solving 0 for x here everything will be 0, and then you'll be left with only the constant, which will be the value of your x. So having explained this thing, let's go ahead and solve the following questions. So the first question I'm going to solve is, if y is equal to s squared minus 9x plus 18, let's graph this function. So remember, the first thing we're going to find here is the vertex. So, and the x-coordinate of the vertex is gotten by negative b over 2a. So let's identify a, b, c in this quadratic function. So we know that the coefficient of s squared is always the a, and here the a is 1. Then b is the coefficient of x, which in this is equal to negative 9, and then c is the constant, which is 18. So to find the x-coordinate of the vertex, we have that x is equals to negative b, our b is negative 9, then over 2a, where our a is 1. So the x-coordinate of the vertex is equal to negative times negative is positive, 9 over 2 is equal to 4.5. So 9 over 2 is equal to 4.5. So this is the x-coordinate of our vertex. Now to find the y-coordinate, now we're going to plug in 4.5 into this equation. Alright, so we have 4.5 square, then minus 9 multiplied by 4.5, then plus 18. So we have y is equal to negative 2.25. That's if you plug in these values in your calculator, you're going to get y equal to negative 2.25. So the second thing we're going to find is the x-intercept. Now, x-intercept is the point where the parabola cuts the x-axis. So know that at any point on this x-axis, the value of y there is equal to 0. So because of that, we're going to equate this function to 0. So we're going to solve s squared minus 9x plus 18 equal to 0, and then find the values of x. Now, the values of x here can be gotten using factorization method, because this is factorizable. Now, if you solve it, so get that the values of x is equal to 3 and 6. So this is the root of the equation. So let me just write the answers we are getting at this side of the screen. So initially we have gotten that the x coordinate of the vertex is equal to 4.5, and then y coordinate is equal to negative 2.25. So again, we got that this is the first one. So second one, we got that the x-intercept is equal to 3 and 6. So the third one we're going to find is the y-intercept, which I said that y-intercept can be found by plugging 0 for the x's here. So if we plug in 0 here, we see that 0 squared is equals to 0 minus 9 times 0 is 0, then half plus 18. So if you evaluate this, you see that 0 minus 0 plus 18 is equal to 18. So the y-intercept here is equal to 18. So y is equal to 18. So let's go ahead and locate these points on these Cartesian coordinates that I've drawn. Now the scale I used here for x-axis, 1 cm is going to represent 1 unit. So I assumed each box here to be 1 cm, that is from this point to this point to be 1 cm. I also assumed that from this point to this point is 1 cm. Now we are going to be using 1 cm to represent 1 unit on the x-axis, and also 1 cm to represent 2 units on the y-axis. So 1 cm to represent 1 unit on the x-axis, you start with 1, then 1 plus 1 is 2, 2 plus 1 is 3. It will be increasing by 1. Whereas 1 cm to represent 2 units on the y-axis, so you start with 2. So 1 cm to represent 2 units, you start with 2. It will be increasing by 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. And then the same thing is applicable to the negative y-axis and then negative x-axis. So let's go ahead and locate all these points on this graph. So starting with the vertex, so we have that when x is equal to 4.5, y is negative 2.25. So we have that this is when x is 4.5, so this is our 4 here. So in between 4 and 5 is 4.5. So and then when x is 4.5, y is negative 2.25. So this is 4.5 is going to come down here, and then y is negative 2.25. So negative 2.25. So in between negative 2 and negative 4 is 3. So 2.25 will be around here. So before before 3. So let's assume that this is where it is. So this is where the two line met. Alright, so we mark it as 3. So next thing we're going to do is to locate the roots of the functions. So let's locate x is equals to 3 and 6 on this Cartesian coordinate. So on the x-axis, on the positive side, positive 3 and positive 6. So this is positive 3 here. Wait, let me use this thread. So this is positive 3 here, then this is positive 6 here. Next thing we're going to do is to locate the y-intercept. So the y-intercept here is equal to 18, and so this is the point here. So equals to this 18 here. So next we're going to do is to connect these dots, this dot, this dot, and then this dot. Alright, so I'm going to use freehand to connect it. It might not be perfect, but I just hope it comes out nice. So yes, so we're going to connect it this way, and then up like this. Yes, so this is how this function will look like. So this is how to graph this function, y is equals to x squared minus 9x plus 18. Alright, so let's go ahead and solve another question. So the next question we'll be solving is y is equal to negative x squared minus 5x minus 6. First, let's find the vertex. So the vertex of this function, so we have x is equals to negative b over 2a. So this is equals to, then here our a is equals to negative 1, the coefficient of x squared, b is equals to negative 5, the coefficient of x, and then c is equals to negative 6, the y-intercept. So negative b is equals to negative 5 over 2a, 2 times negative 1, we have 2 into negative 1. So negative times negative is positive, we have 5 over 2 times negative 1 is negative 2. So 5 over negative 2 is going to give us negative 2.5. So let me write it here. We have that our vectors is x is equals to negative 2.5. Now to find the y-coordinate of these vectors, we substitute x here for negative 2.5. So we're going to have negative, we have 2.5, also negative here again, square minus 5 into negative 2 0.5 minus 6. So if you plug in this in your calculator, you're going to get that y is equal to 0.25. So the second step is to find the roots of the equation, which is the x-intercept. Alright, so we're going to equate this to 0 and then solve for the value of x. Solving it quadratically, you're going to get that x is equal to -3 and -2. Alright, so the third thing we're going to find is the y-intercept. So y is equal to, if you substitute 0 for all the x here, you're going to get that y is equal to -6, because -0 square minus 5 into 0, all of this is going to give you 0. You will be left with -6. So y-intercept is equal to -6, and then we're going to, let's just write them out here. So the x-intercept are x is equal to -3 and -2, and then the y-intercept is equal to -6. So let's locate all these points, and these are Cartesian coordinates. So the x-coordinate of the vertex is x is equal to -2.5. So this right hand side, we have -2.5 is at this point, and then the y-coordinate is equal to 0.25. So 0.25 moving up just around this point. So let's trace it here, and then it will meet here. So this is the point, and then the second thing is to locate the intercept. So it's -3 and -2. So this is where they are, -3 and then it's -2, and then the y-intercept is -6, so which is at this point. So we are going to connect this point, this point, this point, and then this point. So if you connect it, we are going to get a curve like this. Okay, so yeah, so the curve will look like this. Now this parabola opened downwards because of the presence of this negative in front of the x square, so which is when a is equal to negative value, so as I explained earlier. So let's go ahead and solve the final question. Y is equal to x squared plus 6x plus 9. So let's find the vertex. So we have that the vertex, then the x-coordinate of the vertex is given by x is equal to -b/2a. So let's identify the variables we have here. Then a is equal to the coefficient of x squared is 1, then b is the coefficient of x, which is 6, and then c is the constant, which is 9. Now to plug in all these values here, we have that its answer is -b is 6, then over 2, our a is 1, so -6/2 is equal to -3. So we have that the x-coordinate of the vertex is equal to -3. Then to find the y-coordinate, we plug in -3 into this equation. So I'm going to have -3 square, then plus 6 into -3, then plus 9. So if you plug this in your calculator, you're going to get that the value of y is equal to 0. Alright, so the second thing is to find the x-intercept, and then x-intercept is found by equating this to 0. So when we equate it to 0 and solve, we are going to get that the value of your x is equal to -3 twice. So this is a repeated root. So the third thing we're going to find is the y-intercept. So y-intercept is found by equating x to zeros. So we have 0 squared plus 6 into 0, then plus 9. 0 square is 0, 6 times 0 is 0, 0 plus 0 is 0, 0 plus 9 is 9. So y-intercept is equal to 9. So let's just write the y-coordinates of the vertex is 0, and then the x-intercept is equal to -3. So that is -3 twice, comma -3, and then the y-intercept is equal to 9. So let's go ahead and plot all these points on this Cartesian coordinate. So first, let's plug in value of -3. So yeah, here is negative 3. So when x is negative 3, y is 0. So just at this point, nothing more, nothing less. So then the roots of the equation is x is equals to negative 3 and negative 3. Wow. So the roots of the equation is 3 at that point. So the y-intercept is equal to 9. So where is 9? So this is 6, 8. 9 is in between 8 and 10. So this is where it's going to be. So let's connect this dot and this dot. So the graph is going to look this way, yeah, and then it will move up. All right, so this is how this one is going to be. Now this is true because if you calculate the discriminant of this equation, you see that the discriminant is equal to 0, because here b square minus 4ac is the discriminant, then b square is c square is 36. So 36 minus 4ac, 4 times 1 is 1, 4 times 9 is 36, 36 minus 36 is equal to 0. So when the discriminant of a quadratic equation is equal to 0, it's going to have one repeated root, so which is what we have here. X is equals to negative 3 and negative 3, and this is how the graph is always going to look like. So thank you for watching. Please remember to subscribe to my YouTube channel, share with your friends, like my videos. Have a nice day.